Alright guys, just as an aside to our little Ninja Adventure tutorial, I just want to show you something that I've been playing around with here. There's plenty of ways to do something like this for a game like a turn-based tactical game where you've got your player and you want to know how far they can move, and so you move and you click and they move there. But actually doing it and implementing those algorithms can be quite difficult, especially if you don't have like a computer science background and you don't know about queues or stacks or different algorithms like Dijkstra's algorithm or A-star algorithm or depth first, breadth first searches, all these kind of things that you learn about when you do a computer science degree. So what I thought I'd do here was keep it simple, and I'm going to look for paint. I'm going to do one of my really cool grids here, and I'll just throw one of these down here, and I want to talk about how the grid system works in GameMaker. And I'm going to give you the code to do this. What you do with it is up to you. You could implement it in something, or you just might want to look at it out of interest. So there are a few different kinds of grids in GameMaker. We're going to be looking at two. The DS grid, which stands for data structure grid, it's a 2D list, and the motion path grid. So I'm going to come back to this in a second, but I'll just close this program down here. Well, what this does actually, I didn't explain it. If I click here, you can see the distance to go to all these locations traveling orthogonally. So 1, 2. The distance from here, I'd probably subtract 1 from the number. That would make more sense. So it would go 1, 2. Instead, it's 1, 2, 3, 4, 5, 6, 7, 8 to get to there. And that's the shortest distance. If I click here, the shortest distance it can go is to here. I've got the movement set to 8. So we can't go any further than that. So 2, 3, 4, 5, 6, 7, 8, 8, 8, etc. And I can't reach this spot here, but if I move to there, I'll be able to reach that spot, etc. So I can kind of move around, and this will update manually. All the numbers update, and it's really fast. It is really fast, even though the way I'm doing it is probably not the most efficient, but it will hopefully make sense. So what I've got here is I've got an object called OBJ grid, and what this does is it creates a grid for a motion path grid. So this function here, MP grid create, I may zoom this in, F7, no, F8, F8 makes things bigger. Don't want that. We'll get it like that. Okay, so MP grid create. One other thing I have done is under macros, I have just set up a macro called cell size 32. This is essentially a constant variable. So whenever I type the word cell size, it has the value 32. If I want to change my room size, I can go in and change this here. The grid starts at 0, 0, and it goes for room width. This is the number of cells. So room width divided by cell size. So if room width is 1024, 1024 divided by 32, I'm going to get 32 cells across in this grid. And this is all done in memory. Room height divided by cell size. So my room height is 768. It'll probably give me 24 grid units down. And then the actual grid size. So how big is each unit? Cell width, cell width, cell width, cell height. And they're the same. So I'm just putting cell size in both. And then what I do is I add in the instances. Okay, these are the instances that are going to be blocked off on the grid for motion tracking. So I won't be able to find a path to these places, because wherever I'm drawing the path from, it will not be able to calculate it to it there, because it is not a location that I want to be able to move to. So with that done, if I quickly just add an event called draw and type draw grid, no, it's MP grid draw, and I'll draw the grid, and I run this, I should see my grid being drawn. So there it is. The green areas are areas I can move to. The red areas are blocked off areas. So I can get rid of that. I don't need that once I've done it. Okay. I'll close that. In my room, what I've got is I've put that MP grid there, and I've just made an object. That's just object wall You can see in object grid that that's the wall that's getting added to it. Pretty straightforward. So that's that bit, which I'll refer to from different objects. I've only got one object here, and it's object player, which I've called it that. The create event is fairly simple. And in fact, I don't even need the step event for this basic bit to work. I've just put the step event in so that I can change it and test it easily. But the create event, this is the entire code. It doesn't draw the thing on the screen, but that's the entire code there. Now I want to explain this. So the first line here, G equals object underscore grid dot grid. There's object underscore grid dot grid. And it's just because I don't want to have to type this all the time. So I'm just making it pointed to that. And then path equals path add. We're going to use paths quite a lot, and paths are really useful in determining the distance. So if I go back to here, let's just say that these are the walls on my grid. So these actually have a value of -1. So I'll just put that in on a few of them. So that's -1, -1 for all those, -1, -1, -1, -1. And any area that I can traverse is a 0. So there's only two values in that motion path grid, 0 and -1. All these white squares are going to be 0. And now I add a path. So what I'm going to do, I'll go back to here, I'll put my player object somewhere here. There's my player object, and I'll put P for player. So now what I do, I just set up a few variables. A new grid, this is a different grid. This is a DS grid. Okay, it's a data structure. It's in GameMaker. It works pretty much the same way as MP grid. In fact, the MP grid uses a DS grid to store the values. But what I'm doing here is creating a grid the same size as the motion path grid. So room width, cell size, and room height, cell size. I'm making a grid. XX equals room width divided by cell size. So I'm getting the cells across. YY, I probably should have named this better, like width or something, height. That's just getting the cells down. There are other ways I could have done that, but that seemed to work fine. So essentially, I'm just getting this and this. There's probably a better way I could have done that, like write WH equals and then put it in. Player X equals, so this is the location of the player. X div cell size. And the reason I put div there instead of divided is because I want a whole number for this, or it could cause some issues. Now I do a for loop. I do a double for loop. So for I equals 0, I is less than XX, I plus plus. For j equals 0, j is less than yy, j plus plus. So what this essentially does is it goes, for this bit here, we're going to do all of that row and calculate it. And then we're going to go to the top of this one and do all of that row and calculate it. And then I is going to be equal to 2, and it's going to go through all the j's, which are the columns. And then I is equal to 3, and all the j's, which are down here, etc., all the way across. So from top left down to bottom right, it's going to do this. Loop through each location in the grid, determine the shortest path to the location, get the number of nodes in the path. And this is really cool. We need to understand how GameMaker paths work. Store in local grid, clear the points on the path. So let's say we're working from this one. I'll make my pen color green, and I'll make the size a bit larger. So what we're doing here, it finds the fastest path at this point, and it uses A star, I think. So we don't need to worry about calculating that algorithm. It's already built into GameMaker. And so we go, this here is the starting node. I may actually end up, I think I start from here. Let's have a look. If the cell is not -1, so if we can actually reach it, then I start from player, I do X start, so I start from the player's location. So back here, I start from the player's location, and we calculate the fastest point to there. Now there's loads of different ways I could go, so I could go here, 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 all the way down here, etc. But the algorithm calculates the fastest point, which is from here to here, to here, to here, to here, to here, to here. Okay, using the least number of turns. Now, the way that paths work is every single one of these instances on the grid has a node on it. So if we want to see how long this path is, all we need to do is count the number of nodes on a path. And that's what I've done here. Variable value equals path get number path, the path that we just created using MP grid path. And so this one has 1, 2, 3, 4, 5, 6, 7, 8. Or if we're counting from here, 2, 3, 4, 5, 6, 7, 8. And then I just add that to the little local grid that we made. So DS grid set, the local grid, IJ, whatever value we're checking, put the value in there and then clear the path out. That way the path goes back to 0. And if it's a -1, so if it's a wall area, it just puts a 0 on there, and that's a 0 distance. We could maybe put like a different value on there, etc. But that's fine because you won't be able to click on a wall. And that works really well. And then it goes on to the second point. So it comes to this one here going down, and it figures out, oh, that's 7 away. And then we come to this one and we figure out that's 8 away, and then that's 9 away, and then that's 10 away. And then it does the same thing for the rest of them. And that's it. It's really easy. There's not much more to it. All I've added into mine is a function that draws it. So if I go object player, the draw function, all I do is just draw the grid out. So it's the same thing. I'm looping through everything there. S equals get the value from out of that local grid and draw it. Pretty straightforward. I don't need even to draw a path. And then I set the alpha to 0.5, and I just, once again, loop through everything in the list. Draw color. If the DS grid get value is less than 9 and greater than 0, then I draw a rectangle at that location, a little bit smaller than it. And this is what ends up happening. So I could use this code in something. So I could create a little game that works similar to this. So if I'll just stop this, and I'm pretty sure I've got an example game, new IDE. This always takes forever to do. There we go. And I click on that. So I've got something similar. So I could actually use it in a little game like this, which does some basic pathfinding to limit how far this little dude can travel. So at the moment, he'll go to wherever I click, but he won't go to these wall areas. He won't go here. He won't go off there. He'll only go to the areas that I click, but I could limit it because maybe I only want him to be able to move 1, 2, 3, 4, 5, 6, 7, 8 spaces. At the moment, he can go all the way over there, draws that path, but I could utilize that, figure out how far away different locations are, and then say, well, if I click on this area and if it's greater than the distance that he can actually travel on his turn, too far, too bad, pick something different, highlight the areas that he can travel in. So I can use it for different purposes.